medyo mahaba-haba pa po to. Okay, let's resume. Yan po. Let's go with our Krebs cycle. So, this is our Krebs cycle. Wala pa ako naka-upload ng Krebs cycle, pero may na-upload ako for glycolysis. Nasa lipids folder. Yan. So, ito na yung Krebs cycle natin. Yun nga lang, ito na part, yan, take note na ito na part sa itaas, ito yung kanina yung in-explain ko sa inyo na pyruvate oxidation natin, in which we need to, kailangan natin gawing acetyl-CoA yung pyruvate molecules natin. Okay? So, take note lang, ito yung pyruvate oxidation natin na nangyayari. So, take note, yung goal natin dito is makagawa tayo ng acetyl-CoA kasi si acetyl-CoA, siya yung requirements natin for the Krebs cycle natin. Now, another thing is, acetyl-CoA can be also get from our beta oxidation. So, hindi lang siya nakukuha sa glycolysis. Kaya nga, di ba kanina, doon sa enzyme regulation natin, as I mentioned, na how comes na biglang mag-i-increase yung level ng ating citrate. Yan. So, kasi might be, some of the acetyl-CoA comes from our beta oxidation. Yan. So, let's just focus lang dito na part. Yan. Pagdating natin dito sa acetyl-CoA. So, yung step 1 natin, once again, may numbering siya. Yan. Paki-check kung 8 ba. May iba sa inyo 9. Yan. Siguro may iba sa inyo 9. Yan. But eventually, yung 8 lang yung i-focus ko. Particularly, the citrate, synthase enzyme, aconitis, isocitrate dehydrogenase, alpha-ketoglutarate, succinyl-CoA, succinate dehydrogenase, and we have the fumarase. Yan yung main na, meron pa pala, enmalate dehydrogenase. Yan. Yan yung 8 main enzyme na itatopic ko. Kung may nag-9 sa inyo, okay lang po. Wala akong problema. Pero, may sobra siguro dyan na isa. Sige lang, ano lang natin yun mamaya sa reactions natin. Check ko lang ako. Okay. Sige. So, let's go with the step 1 natin. So, sa step 1 natin, gagamit tayo ng enzyme na citrate synthase natin. So, for the citrate synthase natin, take note na may dalawang molecules tayo na i-utilize dito. We are going to utilize acetylcitrate and oxaloacetate. Oxaloacetate is a 4 carbon molecules galing doon sa previous cycle ng ating Krebs cycle. Ngayon, since 4 siya, yung goal natin dito is to produce a citrate molecule, which is a 6 carbon molecules natin. That's why si acetyl-CoA, which is a 2 carbon, plus a 4 carbon oxaloacetate natin, it forms the citrate enzymes natin. Citrate natin na substrate. Sorry. Citrate is a substrate. So, take note, acetyl-CoA plus oxaloacetate with our enzyme citrate synthase natin, it will form a citrate molecules. Now, take note, ano yung lumabas at ano yung pumasok dito sa molecules natin. Since in acetyl-CoA, meron tayong coenzyme A na doon sa sa acetyl-CoA. Pagdating natin dito sa citrate synthase natin, lalabas yung coenzyme A natin. Lalabas si coenzyme A, papasok, may water molecules. Kumbaga ba, si water molecules yung mag-fill in sa kulang or sa part ni acetyl-CoA natin, forming a citrate molecules natin, which is a 6 carbon natin na molecules. Now, these citrate molecules naman natin, with the enzyme aconitis, aconitis, magiging isocitrate siya. So, kung papansinin natin dito si aconitis, yan, yung enzyme natin, aconitis, nagkakaroon siya ng isomerization. So, nire-restructure niya lang. Actually, Actually, some of you, kung napansin nyo, may iba sa inyo na 9 yung inyong enzyme. Kasi pagdating dito na part, particularly ito na part talaga, silang dalawa, may another step dito. Kumbaga ba, dinetailed kasi nila na in this step, nagtanggal ng hydrogen, tapos binalik na naman yung hydrogen. Yan. So, in this reaction kasi, kailangan nilang magtanggal ng hydrogen para magkaroon ng movement yung molecules natin. Pag na-move na, yan, pag na-position na sila sa dapat position na dapat sa kanila, doon pa babalik yung hydrogen natin. Okay? That's why yung iba sa inyo, 9. Kasi, nagkaroon ng extra dito. But actually, we could just summarize it to a conitase na enzyme. Yan. Mama, mnemonics ka po ba sa Krebs cycle? Sorry, I don't really use mnemonic pagdating sa Krebs cycle. Ginagawa ko na lang is more on, yung hint ko talaga is sa enzyme. But sa internet, I'm sure marami kayong makikita ang mnemonics. Yan. Hindi ko kayo pipigilin kung kailangan yung gumamit ng mnemonics. Yan. Okay? So, you try na lang to search, or kung gusto nyo, kayo yung gumawa ng mnemonics para mas madali nyo siyang maalala. Yan. So, I will use this one Step 1, Step 2 natin. Yan. So, this is the Step 2 natin. Yan. So, in this part, citrate loses one water molecule and gains another as a citrate natin. So, ito yung na-mention ko kanina na if some of you na nagkaroon ng problema dito na part, yan, kasi yung enzyme natin, dalawa yung enzyme dito. So, yun lang po yung difference nila. Dito sa slides ko, sinamarize ko na may yung paglabas at saka pagpasok ng ating hydrogen molecules natin. Now, for the step 3 naman natin, from isocitrate molecules, magiging alpha-ketoglutarate siya with the enzyme isocitrate dehydrogenase. If we are going to observe this reaction, yan, take note, isocitrate dehydrogenase. Dehydrogenase yung gamit. Yan. Like I've said, pag dehydrogenase yan, involves si NADH or FADH. Yun nga lang, in this case, yung reaction natin dito, yung involved dito is our NAD molecules natin. So, isocitrate dehydrogenase, therefore, si isocitrate, kailangan niyang matanggalan ng hydrogen. So, pag natanggal na yung hydrogen niya, ibibigay niya kay NAD so that NAD will become NADH. Then, this isocitrate will become an alpha-ketoglutarate natin. If you are going to observe the alpha-ketoglutarate, ilang carbon to? 1, 2, 3, 4, 5. Take note, from 6 carbon na isocitrate natin, naging 5 carbon na lang siya. So, another thing na nangyayari pagdating dito is there is a release of carbon dioxide in the reaction. Okay? Nakuha?
Yes, ma'am.
So, take note, isocitrate dehydrogenase, yan, nag-release ng NADH molecules and ang carbon dioxide. So, kung titingnan natin yung product natin dito, we have the NADH, we have the carbon dioxide, and we have our alpha-ketoglutarate natin. Step 4 natin, we have alpha-ketoglutarate oxidized, reducing our NAD to NADH natin. So, in our step 4 natin, from alpha-ketoglutarate, magiging succinyl-CoA siya. Now, take note, succinyl-CoA, coenzyme A. So, kung titingnan natin sa reaction, biglang pumasok yung coenzyme A natin dito. Therefore, sa one of our reactant or substrate na nakikita natin is the entry of our coenzyme A. Another thing, syempre, kung papasok si coenzyme A, dapat may position siya. So, para para magkaroon siya ng position, kailangan matanggal yung carbon dioxide natin. So, another carbon dioxide is released. Another thing, since we are using the alpha-ketoglutarate dehydrogenase, involve ulit yung dehydrogenation or dehydrogenase natin na enzyme. So, therefore, involved na naman yung another NADH molecules natin. So, in this reaction natin, yung product natin, we have the, again, carbon dioxide and NADH natin. So, kung titingnan natin din dito, si alpha-ketoglutarate na merong 5 carbon, naging 4 na lang. Kasi may na-release man na carbon dioxide. Next, for the step 5 natin, we have the succinyl-CoA, releasing a succinate natin na substrate. So, we are using here the succinyl-CoA synthetase natin. So, dito, kung pumasok kanina si acetyl-CoA, this time, lalabas na naman si acetyl-CoA natin. Another thing dito is may papasok na inorganic or may papasok na independent phosphate group sa reaction natin. Yan. So, pagpasok, eventually lalabas din naman siya. Yan, mag-a-attach siya doon sa GTP natin. Yan, sa GTP, forming a GTP. Ma'am, ano yung GTP natin? Guanine, triphosphate natin. Ang mangyayari dito, yung equivalent ng isang GTP natin is equivalent sa 1 ATP. So, parang energy din to. Yan, yun nga lang in the form of GTP natin. So, later yung succinyl-CoA maging succinate with the enzyme succinyl-CoA synthase natin. Then, yung succinate naman, with the help of our enzyme succinate dehydrogenase, ito dehydrogenase, yun nga lang, si FADH2 yung involved natin dito. So, forming si succinate natin, magiging fumarate siya. So, dito involved is FADH2 na natin. So, this is the first time I think na gumamit tayo ng FADH or nag-release ng FADH. Kasi kanina, yung mga pinagagamit natin is NADH. So, take note, in the Krebs cycle, yan, isa lang po yung enzyme na nag-utilize ng FAD molecules. And that is our succinate dehydrogenase. Now, in step 7 natin, from fumarate natin nagiging malate, in which there is an addition of water molecules para ma-restructure siya to malate natin. And this malate will become an oxaloacetate natin. So, with the enzyme malate dehydrogenase. So, another dehydrogenase enzyme na ginamit, NAD papasok, lumabas as NADH. Okay? So, nagiging oxaloacetate. Yung isa sa mga last step natin for the Krebs cycle. And this oxaloacetate, gagamitin na naman siya to form acetyl-CoA, to form acetate molecules natin. So, kaya siya tinawag na Krebs cycle. Now, ano ba yung product natin ng TCA? Ano yung mga product na naibibigay ng TCA natin? So, kung napansin natin, meron tayong 3 NADH molecules. Particularly, saan na part? Saan nag-release ng NADH? Number ng enzyme, please. Number 4. Ano pa?
8, ma'am.
And number 3. Okay, very good. So, we have number 3, number 4, and number 8 natin, in which nag-release tayo ng NADH natin. Take note ha, isang cycle yan siya ng acetyl-CoA. Yan. Next, another is FADH2 natin, particularly in step number 6 natin. Then, we have the 1 GTP or ATP in step number 5, and dalawang carbon dioxide natin, particularly in step number 3 and step number 4 natin. So, ito yung mga product natin sa bawat isang cycle ng TCA natin. So, kung titingnan natin, sino dyan yung energy natin, sino sa kanila yung energy natin dyan? Yan, 3 NADH, isang FADH, isang GTP. Isang cycle pa lang po yan ng acetyl-CoA. Yan. So, therefore, pagdating natin sa process ng glycolysis, ilang pyruvate yung na-produce sa glycolysis natin sa isang molecules ng glucose? Ilang pyruvate?
2, ma'am. Dalawa.
So, therefore, pagdating dito sa yung pyruvate natin, pagdating sa Krebs cycle, times 2 rin. Yan. Sa isang glucose molecules. Nakuha lang?
Yes, ma'am.
Now, naalala yung sa beta oxidation na na-mention ko na mas maraming na ipoproduce yung na energy yung fats natin compare with our glucose. Kasi kung imagine ninyo, kung nakaproduce yung natin, if we have 14 carbon, that is equivalent to 7 acetyl-CoA. Yan. So kung 7 yung acetyl-CoA, times 7 din yung product na mapo-form nito. Yan. Ganun karaming energy. Yan. Okay, so we have the electron transport chain natin. Another thing. Yan, so in our electron transport chain natin, known as our oxidative phosphorylation natin. So take note, we have our byproducts. We have the NADH and our FADH2 natin. Hindi ko na siya babasahin ha, sorry. I will just summarize this one. And I would really recommend you to read or to watch the video na nirecommend ko doon sa courses natin. Kasi doon lang po ako nagkuha. Mas simple kasi yon. Yan. So take note, pagdating natin sa electron transport chain natin, you need to familiarize the following complexes. Complex 1, 2, 3, 4, and we have our ATP synthetase natin. So complex 1 known as NADH dehydrogenase, complex 2 known as succinate dehydrogenase, complex 3 we have the cytochrome C reductase, complex 4 we have the cytochrome C oxidase natin. And we have our other protein factors natin. We have the coenzyme Q10 or ubiquinol, and we have the cytochrome C complex and the ATP synthetase natin. So take note, ito yun sila. Complex 1, the NADH dehydrogenase. Complex 2 natin, the succinate dehydrogenase natin. Complex 3 natin, we have the cytochrome reductase. Then complex 4, we have the cytochrome oxidase natin. So we have the Q10 natin ng mga Q10, and we have our cytochrome natin na mga complexes and the ATP synthetase. Okay? So, ano bang mangyayari dito sa reactions natin? So, take note, we have the NADH molecules natin. NADH and FADH. So, unahin natin si NADH. Ngayon, itong NADH kasi natin, dito yan siya mag-a-attach sa complex 1 natin. Now, take note, sa bawat attach niya sa bawat hatid ng NADH natin, ng hydrogen molecules ito sa complex 1 natin. Yan. Doon sa inner mitochondria natin, may nagpapump na 4 na hydrogen ion. Yan. So, example, NADH, attach siya dito. So, automatic, we have these 2 electron, and these 2 electron will trigger the complex 1 to release 4 hydrogen ions. Yan. So, later, yung electron natin, magta-travel yan siya. We have our, dito na, we have our coenzyme natin na Q10. Yan, si Q10 natin. Ang gagawin ni Q10, ihahatid niya itong electron na to from complex 1 to complex 3. Yan. So, ihahatid niya from complex 1 to complex 3. Na pagdating natin sa complex 3, yan, iti-trigger niya yung complex 3 natin na mag-release ng another 4 hydrogen ions natin. Now, this electron na naman, ihahatid siya ng ating proteins natin or coenzyme natin, yung cytochrome natin from complex 3 to complex 4. Then, pagdating natin sa complex 4, may marirelease na another 2 hydrogen ions. Ngayon, yung electron na yan, lalabas. That's why dito napapasok yung oxygen natin for the aerobic respiration. Yan, in which kakailanganin natin ng oxygen para mag-form tayo ng product natin na water molecules. Ngayon, yung important dito is yung mga hydrogen ion na nare-release. Yan. Ito yung pinaka-importante. Kasi, sa mga nare-release natin na hydrogen ion natin, yan, pagdating natin kay ATP synthase natin, i-collect niya yan. I-collect yan ni ATP synthetase natin. So, as the ATP synthetase collect it by 4, yan, sa bawat 4 na hydrogen ion, may nare-release na isang ATP. Okay? Ngayon, that is for the NADH natin. So, kung bibilangin natin yung NADH natin, ilang hydrogen ion lahat yung nare-release niya? So, So, 4 plus 4 plus 2, meron siyang 10 hydrogen ion na nare-release. Ngayon, si ATP synthase, by 4, di ba yung paggawa niya ng ATP? So, if you are going to divide that 10 divided by 4, merong 2.5 na ATP na nare-release sa isang NADH natin. Ma'am, how about naman yung FADH natin? Sa case ng FADH natin, hindi siya dadaan sa complex 1. Si FADH natin, dadaan siya sa complex 2 natin. Yan. So, FADH2 natin, mag-a-attach sa complex 2. Then later, yung complex 2 natin, ihahatid niya yung yung Q10 natin, ihahatid niya yung electron sa natin, sa 3. Magpapump siya ng 4 hydrogen ion. Then later, dadaan na naman siya sa complex 4, in which magpapump siya ng 2 hydrogen ion. Ngayon, sa isang FADH natin na molecules, meron lang tayong 6 na hydrogen ion na napapump. So kung 6 lang yung hydrogen ion natin, and si ATP synthase natin by 4, yan, si FADH natin, nakakapagbigay lang siya ng 1.5 ATP molecules. Yan. Kaya yung na-mention ko kanina that in every NADH that is equivalent to 2.5 ATP, and in every FADH that is equivalent to 1.5 ATP molecules po natin. Nakuha? Hello? Naintindihan pa ba ako? Question, be? Walang tanong? Or ma'am, wala namin kasabot. Uy, mata pa mo guys? Are you still awake?
Ma'am, ano man ulit yung purpose ng Q at C?
Q at C natin, more on sila yung nag-deliver ng electrons natin from one complex to the next complex. Yan. So I hope maano lang siya ninyo. Ito yung pinakaano kasi na. For me, ito yung pinakagusto ko sa lahat kasi medyo madali lang siya. Tandaan nyo lang, si NADH natin doon siya kay complex 1 mag-a-attach. Si complex 1, 4 na hydrogen yung nilalabas niya na ion. Complex 3, 4. Complex 4, 2. Si 2, wala siya nire-release ha. So that's why si NADH natin, nakakapagbigay siya ng 10 hydrogen ion. And pagdating natin kay ATP synthase, by 4 yung kanyang collection para maka-form ng isang ATP. So 10 divided by 4, making it the 2.5 ATP yung nabibigay sa isang NADH. Si FADH naman, since hindi siya dadaan kay 1, so walang hydrogen ions natin dito. Okay? Yan. So, making it na we have here complex 3, dadaan siya kay 4. Meron na lang tayong 6 na hydrogen ion, making it 4, natin. Since by 4 si ATP, forming a 1.5 ATP. Isa lang po. Ilang hydrogen ang nare-release na FADH. Yan. Sige. Take note natin dito, we have here sa glycolysis. Ito, kumbaga ba kung nagbibilang tayo ng ATP. Like example, if we have 1 glucose molecules natin, so we have here sa glycolysis natin, yan, kung meron tayong isang glucose molecule, so sa glycolysis natin, we have the 2 net ATP at saka 2 NADH. I don't know kung naalala nyo pa. Yan, sana naalala nyo. Yan, di ba? So, may 2 tayong NADH doon that is equivalent to 3 to 5 ATP, particularly 5 ATP. Then, pagdating natin sa pyruvate oxidation natin, di ba may na-release doon na NADH. Yan, that is again another 5 ATP. For the citric acid cycles natin, di ba merong isang ATP, 3 NADH, tapos isang FADH. Since sa glycolysis natin, 2 yung ating pyruvate, kaya siya na times 2. Kaya siya naging 2 ATP, 6 na NADH, at 2 FADH. So, that is equivalent to 2 ATP, we have 30 to 32 ATP. Ay, may isa pa pala. Sorry. Yan. So, beta oxidation, ito lang. Siguro summary ko na lang tong beta oxidation. Take note sa beta oxidation, this is the degradation of our fats, fatty acids. Yan. So, occurs in our mitochondria of eukaryotic cells and in the cytosol naman ng prokaryotes natin. So, happens before, however, before this happen, fatty acid must first enters the cell and in the case of eukaryotic cell, inside the mitochondria. Kasi diba, beta oxidation happens in the mitochondria. Now, take note, in the steps of beta oxidation, meron tayo ditong 4 na klase na steps natin or main step natin. Particularly, dehydrogenation, hydration, oxidation, and we also have our tyolysis natin. So, now, take note, paano ba nakakapasok yung fatty acids natin sa loob ng cells natin? Sa loob ng, particularly ng inside our cell, para makapunta din siya doon sa mitochondria mismo natin. So, we have here example natin fatty acids. Wait lang. So, if we have the fatty acids na nandito, yan, this is outside the cell and inside the cell. Ngayon, we have the fatty acid transporter kung saan dadaan yung ating fatty acid para makapasok siya sa loob mismo ng ating cells. Yan. So, pagpasok niya, we have another na naman na we have the FACS natin. FACS. Sige, ito na lang. Para mas maano ninyo. Kaya eh. Wait lang ha. Wala. katagal. Yan, 9 minutes pala to, sorry. Yan, sige, ito na lang. So, we have here fatty acids. Ulitin ko. Yan. Papasok yung fatty acids natin sa loob ng cells natin. So, we have here the FACS natin, stand for fatty acyl CoA synthetase natin. Yung fatty acids natin, kailangan niya, ang purpose nito is makapag-attach siya ng CoA doon sa ating fatty acid. Kailangan niyang gawing fatty acyl CoA. Yan. Fatty acyl CoA natin. Ngayon, para makapasok siya doon sa loob mismo ng mitochondria natin. Ito, dito sa loob, mitochondria na po to. Ngayon, yung goal natin dito is kailangan nating ipasok yung fatty acid hindi lang sa loob ng cell, sa loob mismo ng mitochondria natin. That's why, gagamit tayo ng mga transporter natin. We have the CPT1 transporter natin and we have also our CPT2 natin na transporter natin. We have CPT1 and CAT natin. Yan. So, in which pagdating natin dito sa natin, si fatty acyl CoA natin, pagdating natin sa CPT1 natin, kailangan niyang mag-attach ng carnitine. So, i-attach niya yung carnitine doon kay natin, kay fatty acyl CoA natin. Yan. And another thing, pag meron na siyang acyl CoA, dadaan siya dito sa ating CAT molecules natin. I mean, transporter natin. Itong CAT na part natin. That stands for carnitine translocase. So, dito siya dadaan. So, yung, kumbaga ba, yung gate pass natin is the presence of our carnitine. Ngayon, ang mangyayari, since naka-carnitine siya, may carnitine siya, pagpasok niya sa loob, may carnitine siya, yung goal na naman, yung next goal natin is kailangan nating tanggalin yung carnitine na naka-attach sa kanya. So, para matanggal yung carnitine natin, kailangan niyang dumaan kay CPT2 natin. In which yung purpose ng CPT2 natin, i-detach niya si carnitine sa molecules niya. Tapos pag na-detach na yung carnitine, si carnitine babalik ulit doon sa labas para magsundo ng ibang fatty acyl CoA natin. Ngayon, another thing. So, natanggal na yung carnitine, di ba? So, anong mangyayari doon kay fatty acyl CoA natin? So, si fatty acyl CoA natin, siya na yung dadaan ng ating beta oxidation natin. In which yung mga na-describe ko kanina yung dehydrogenation, reduction, oxidation. Yun. So, yun po yung mangyayari doon. So, like example, kung baga ba nakapasok na yung fatty acyl CoA natin. Yan. So, we have the first step dito. Yan. The dehydrogenation natin. So, in the process of dehydrogenation, magtatanggal tayo ng hydrogen molecule sa acyl CoA natin para mag-form siya ng 2-trans-enoyl CoA. Take note, we use the enzyme dehydrogenation in which involve yung FADH natin dito. So, in this step, yun, involve may nare-release na FADH2 molecules. Another thing, 2-trans-enoyl CoA magiging L3-hydroxyacyl CoA. Yan. So, ang process naman natin dyan is hydration in which gumamit tayo ng water molecules. Yan. With the enzyme enoyl CoA hydratase para maging L3-hydroxyacyl CoA. Next, we have the oxidation in which we use NAD molecules para ma-reduce siya to NADH. At the same time, yung point dito na oxidation actually is the L3-hydroxyacyl CoA is oxidized and become the 3-ketoacyl CoA natin. So, take note, oxidation, kung papansinin natin, there is an addition of carbon-oxygen bonds natin. So, after ng ating oxidation, yan, we also have the thiolysis na po na nangyayari. So, in the process of thiolysis natin, yan, so, papasok yung coenzyme A natin, coenzyme DNA natin, forming an acetyl-CoA and an acyl-CoA. Ang mangyayari kasi dito, example ha, we have the example natin, yung acyl-CoA natin is 14 carbon yan. Yan. So, 14 carbon, magiging dadaan ng dehydrogenation, dadaan ng hydration, oxidation. Ngayon, pagdating kasi natin dito na part sa 3, sa 3-keto-acyl-CoA natin, ang gagawin niya, magkukos siya ng breakage. Kailangan niyang putulin yung last 2 carbon na nandoon sa acyl-fatty-CoA natin. So, pag naputol niya na yung last 2 carbon natin, yun na yung acetyl-CoA. And this acetyl-CoA, proceed na yan siya doon sa Krebs cycle natin. Ngayon, 14 minus 2, meron pang 12, di ba na naiwan? So, yung 12 carbon na naiwan, balik ulit sa cycle. Yan. Hanggang sa maubos yung 14 carbon natin. Kaya yung na-mention ko dati na pag meron kang 14 carbon na fatty acids, yan, eventually, maglilid na yan siya to 7 acetyl-CoA. And that acetyl-CoA proceed with the Krebs cycle. Yan. So, energy yield and end product ng ating So, each beta oxidation cycles yields 1 FADH2, 1 NADH molecules natin, and 1 acetyl-CoA. Sa isang cycle lang po yan. Okay? So, it means kung meron kang 14 carbon, that is equivalent to 7 cycles. Yan. So, kung i-compute natin yan sa bawat isang FADH, that is equivalent to 2 ATP, in every NADH, equivalent to 3 ATP, tapos in every acetyl-CoA, that is equivalent to 12 ATP. Ito kasi kung kung dadaan na siya sa process ng Krebs cycle. Yan. So far, yun lang yung may bibigay ko sa inyo na topic na coverage natin. Now, may nag-question kanina, sana yun? Magpasa pa ba ng ibang metabolic pathway? Di ba nagpasubmit ako ng lahat ng assignment, isasubmit po yun. Okay? Pati yung pentose phosphate pathway. Yung pentose phosphate pathway, hindi na talaga kaya ng oras natin. Hindi ko na rin siya isasali sa exam. But sana naintindihan nyo yung drawing ninyo ng pentose phosphate pathway. Yeah. So, as I've explained kanina, ginagamit natin ang pentose phosphate pathway para makagawa tayo ng mga macromolecules like RNA, DNA natin, yung mga nucleotides po nila. Yun. Doon yung main purpose ng ating ng ating pentose phosphate pathway natin. Maggagawa lang po ako ngayon for the submission, yung assignment task natin. Okay? Sige lang. Ano na lang hindi nyo napasa?
PCA, ma'am, ABC, tsaka yung PPP niya.
Okay. Krebs cycle, TCA. Wala pa ba ang TCA?
Wala, ma'am. Glyco... Disease o gluconeogenesis pa lang itong kasama.
Nakalimutan ko. Sige.
Ma'am, yes ma'am. Ma'am, i-add po namin dun sa ipasa yung pentose phosphate pathway, ma'am. Wala mo po kung ipagawa yun last time.
Wala ko nagpaano ng PPP?
Yes, ma'am. Ngayon mo lang dimension mo.
O sige, kung walang PPP, wag na. Okay na yan.
Okay, ma'am. Thank you, ma'am.
Okay, thank you, ma'am.
Wait lang ha, yung category assignment. Okay, naka-publish na, naka-post na ako. TCA, ATC, and beta oxidation. Yan. Then, tama pala. Quiz. Yan. Quiz for today. This will be by group. Yan. Take note ha, this is a quiz. So, by group nyo siyang gagawin, tutulungan nyo. I'll give you time until siguro mga tomorrow. But this is recorded somehow as your quiz. Yan. You are going to answer the following. Eto. So, you are going to fill the table. Like example sa glycolysis, saan siya nagtitakes place? Yan, particularly sa part ng cells natin, ribosomes, endoplasmic reticulum, saan ba yung kanyang Then, yung mga product natin nandito na, pyruvate, NADH, and ATP. So, ilalagay nyo ilan yung, ilan yung product na nare-release niya. Yan. Ilan yung pyruvate, ilang NADH, ilang ATP yan. Okay? Dito sa glycolysis in every glucose molecules. Then, ano yung mga enzyme na responsible dito? Yan. So, sino yung enzyme na nag-release ng pyruvate? Sino na mga enzyme ang nag-release ng NADH? Sino yung mga enzyme na nag-release ng ATP? In beta oxidation naman, we have the following product, NADH, FADH2, acetyl-CoA. So, you are going to indicate ano yung ilang number of product. Yan. Ito, in one cycle lang yung beta oxidation natin. Then, enzyme na mga responsible. Pyruvate decarboxylase natin, in one molecules lang of pyruvate. Yan. So, sa isang pyruvate natin na molecules, ilang NADH, ilang carbon dioxide, and in citric acid natin, in every acetyl-CoA natin, ilang GTP, NADH, FADH2, tsaka carbon dioxide. So, at the same time, ano yung enzyme na responsible sa kanila? Then we have also the beta oxidation and the citric acid cycles natin. So, dito, i-identify nyo sino yung mga enzyme na isomerization, sino yung mga dehydrogenase enzyme natin, and sino yung mga enzyme natin na hydration or hydratases or hydration natin. Yan. So, this is by group. Yan. And you are going to answer it siguro mga group leaders lang yung ilalagay ko. Please, group leaders lang yung magta-submit. Tapos, take note, group leaders, paki-indicate po yung members talaga na tumulong sumagot nito. Nakuha? Yan. Particularly who are present today. Yan. So, it will be unfair. Kayo bahala. It will be unfair in your part kasi recorded to as quiz. Nakuha? So, as much as possible, I want you to be honest who are the members who really take effort na sumagot dito sa quiz na ito. Yan. Parang sa amin quiz na ito eh. Nakuha? Wala. Question.
Yes. Ma'am, ang groupings po sa lab,
Ano?
yung groupings po
Sa
sa lab,
laboratory na groupings. Same with the section B. Ay, group B. Yan. Okay na? So, any question? Wala. Then, another last thing, sorry ha, dagan kay kung kani siya next week na ninyo siya i-submit. You can submit this next week. But gusto ko lang siyang ipa-assignment sa inyo kasi somehow para at least sana maano nyo siya pagdating sa exam. Wait lang. 8 ata. Ito. So, this is another assignment. Hindi siya quiz, sorry. Assignment to another assignment. Yan. So, you are going to answer the following for the glycolysis glycolysis lang, glycolysis pathway natin. Yan. Yung kanina, yung enzyme, di ba, meron tayong 10 enzyme doon. So, ilalagay niyo yung 10 enzyme.
Ma'am, di po makita.
Ma'am, di po makita, ma'am.
This one. So, ilalagay niyo yung 10 enzyme. Tapos, sa enzyme 1 natin, di ba, we have the glucokinase or hexokinase. So, yung reactant natin doon, yung main reactant natin is the glucose. Yung co-substrate natin is the ATP molecules. Yung product natin, yung main product natin is the glucose 6-phosphate. Yung co-product natin is the ADP molecules natin. Yan. So, yung example na to, nabigay ko na yan siya kanina doon sa ano natin, sa slides, particularly in Krebs cycle. Kung baga gagayahin nyo to. Yun nga lang, sa lahat na ng steps, dali lang. Yan, ito po na part. So, isa-isahin nyo, gaganituhin nyo lahat ng 10 step. So, anyway, next week na yung deadline ko niyan. Nakuha? Hello?
Yes, ma'am.
Individual ito, ma'am.
Ang individual ito. Yung quiz lang yung by group. So, leaders lang yung magsasubmit. Handwritten yung quiz. Sige, yung quiz, okay lang hindi handwritten. I will allow you na hindi siya handwritten. But yung ano natin, yung tawag dyan, yung assignment na glycolysis, handwritten po yun. Okay? Wala nang tanong? So, I think that's all for today. Yan.
Ma'am,
Yes.
ano yung last meeting sa lecture, ma'am?
Next week, lab po tayo lahat. Yan. So, by the way, coverage ng exam. Nucleotides, lipids, metabolic pathway. Particularly sa metabolic pathway, glycolysis, Krebs cycle, electron transport chain. And beta oxidation. Beta oxidation. Kailangan yun eh. So, yun po yung coverage ng exam ninyo. Purely multiple choice lahat. Wala na tanong? Yan. I think that's all for today. Please have your attendance when you go out sa room. Yan. So, thank you, students. Konti na lang, malapit na matapos yung semester. Yan. So, malapit na kayong graduate, hopefully, sa biochemistry natin. By the way, for those students who missed some quizzes, can we schedule it po after na lang siguro ng exam? Kung okay lang sa inyo, lahat-lahat na. Yan. Then, please, pakibigyan nyo ako ng listahan kung ano yung mga quizzes na nakulang ninyo. Yan. So, as much as possible, sana, after ng exam natin.
Ma'am,
Yes.
wala na may lab karon, ma'am, no?
Wala nang lab. Dahil na po ngayong araw.
Thank you.
Okay, so yun lang po. Thank you and God bless.